Hey guys, I'm going to start the next section, which is 9.8. So here we are in the textbook, a little crooked. Whoops. So 9.8, we're going to compare linear, exponential, and quadratic models. I recommend that you pause the video and copy the key concept. I'm going to try and focus it a little bit better. My eyes aren't that great. So for me, it could be blurry. Maybe it's clear. No, that's definitely not. Okay. If you have a hard time reading it, I recommend that you open up the textbook itself. You have access and copy this key concept. So when we have a linear function, we have it in this format. The y equals mx plus b. Our exponential, y equals ab to the power of x. And then our quadratic, which we have been learning in chapter 9. So the first example, I'm going to just do it straight from the book. It's pretty straightforward. There we go. Definitely better. It says, use a graph to tell whether the ordered pairs represent a linear function, an exponential function, or a quadratic function. So you would take all the ordered pairs, plot them on a coordinate plane, and then you can physically see what type of graph you would get. So for A, we get an exponential function, which is a curve like this. For B, we get the linear function, which is just a straight line. And then the last one, we get our U-shaped parabola, which is a quadratic function. So I recommend that you pause, copy that into your notes, or you can go back to the textbook and copy it straight from there. So now we're going to be looking at tables to determine whether they are linear functions, exponential functions, or quadratic functions. So to start off, you always look at the y values first and subtract. You want to find the difference. Just like how when we did with sequences, it's always the second term minus the first, the third minus the second, so on and so forth. You're going to do the same thing with the table. You're always going to start with the second term and then subtract. So 5 minus 2, which gives us 3. Then we're going to move on to the next one. 8 minus 5 equals 3. 11 minus 8 equals 3. If the difference comes out to be the same, that means it represents a linear function. From there, that difference represents your slope. To figure out your y-intercept, you go to where x is 0. That's your y. That's where they get the 5 from. For an exponential function, you're going to do the same thing. You're going to start off with the difference. If you notice that the difference is not the same, the next step you should do is to find the ratio. So the ratio is always start off with the second term, like it does here, and then the first term in the denominator. And you divide, and you get 2. Then 1 over 0.5, that gives us 2. And then 2 over 1, which gives us 2. So if the ratios come out to be the same, then you're dealing with an exponential function, which is this format. The 2 is represented as your b. That's what goes in parentheses and raised to the power of x. Then this a it comes from the table where your x value is 0. This is 0.5. So that's where the a comes from. For a quadratic, it's a little bit different. You first start off with taking a difference. If the difference doesn't come out to be the same, or you see some type of pattern, then from that difference, you're going to take a second difference. So you would do -1 minus a -3, which ends up giving us a 2. Then 1 minus a -1, which gives us 2. 3 minus 1, which gives us 2. So for that one, it's a little bit different because they don't really say too much information. So for the quadratic, it's going to be in this format. y equals ax squared. So the first thing you need to establish to determine that it's a quadratic function is you need to prove that the second difference is the same, how they did here. Once you do the first difference, that second difference, if that's the same, then you know it's a quadratic, and it's going to be in this format. And then we're going to end up solving for what the a value is, which is what we're going to do in a later problem. So now we're going to do example 2, which I have here. So the directions say, use differences or ratios to tell whether the table of values represents a linear function, an exponential function, or a quadratic function. So we're going to focus on our y values. Whoops. So this is example 2. We're going to focus on our y values. I'm going to get my calculator ready. Make it simpler. Okay. So we're going to start off with taking the difference from here to here. Remember, you're always going to start off with that value first. So -6 minus a -6. A negative and a negative gives us a positive. So we end up getting 0. So our first one is 0. From here to here. -4 minus a -6. A negative and a negative gives us a positive. And we end up getting 2. Then from here to here, 0 minus a -4, 0 minus a -4. A negative and a negative is a positive, so 0 plus 4, you get 4. Then from here to here, 6 minus 0, and we get 6. We have 6 here. Well, nothing's the same. So I see somewhat of a pattern, so let's do a second difference. From here to here, 2 minus 0 is 2. From here to here, 4 minus 2 is 2. And from here to here, 6 minus 4 is 2. So with the second difference, which I showed here, I kind of gave a list. So for a linear function, we had to have the first difference, which we don't have, so we know it's not linear. For an exponential, it has to do with ratios. We didn't do a ratio. We had to do a second difference. So we know it's quadratic. That was the first thing we need to do, and that was to find the second difference, which all came out to be the same. So that's all we had to prove. We didn't have to write an equation. We just had to determine whether or not it was linear, exponential, or quadratic. So this is quadratic. So that's the first one, part A. Part B is this table. So we're going to do the same thing. We're going to take the first difference with our y values. So 1 minus a -2. A negative and a negative gives us a positive, so 1 plus 2 is 3. From here to here, 4 minus 1 is 3. From here to here, 7 minus 4 is 3. And from here to here, 10 minus 7 is 3. So since we got the first difference all to be the same, that means, so if we go back over here to our different criteria, the difference has to do with linear function. Since all of them came out to be the same on our first difference, this is a linear function. So that was example 2. Here's example 3. Let's look at the direction. So it says, tell whether the table of values represents a linear function, an exponential function, or a quadratic function. Then write an equation for the function. So after we have determined, so for example 3, after we've determined which type of function it is, we're going to write an equation on it. So we're going to start off by taking a difference. So remember, it's always going to be the second one first. So 0.5 minus 2. And we get a negative 1.5. Then from here to here, 0 minus 0.5, and we get negative 0.5. From here to here, 0.5 minus 0, and we get 0.5. And then from here to here, 2 minus 0.5, and we get a positive 1.5. So it definitely looks like a pattern. So now we're going to do our second difference. So negative 0.5 minus a minus 1.5, and a negative gives us a positive. So we have 1.5 minus 0.5, so we get 1. From here to here, 0.5 minus a minus 0.5, a negative gives us a positive. So 0.5 plus 0.5 gives us 1. And then our last one from here to here, 1.5 minus 0.5 gives us 1. So when we look at our criteria over here, which helps us determine what type of function it is, it definitely is a quadratic because we got the second difference to be the same. So now we need to solve for a, because we're going to have our equation in this format. So we're going to have y equals ax squared. Let me put this down. To determine what that is, all you have to do is, it's not in focus. We have to pick an ordered pair to plug in here to solve for the a. So it doesn't matter which one you pick. You can pick any one. I'm going to pick the easiest one. I don't want to deal with decimals. I want to deal with the whole numbers. I'm going to pick this point right here, 2, 2. Of course, the book does not pick that. They pick a decimal, but we're going to make life easy. So don't forget, this is an x. Whoops. This is our y. Going to plug it in here. So y is 2. The a is what we're looking for, and our x value is 2. And don't forget, it's squared. So trying to focus it a little bit more. So now we're going to start to simplify. Well, 2 is equal to a. 2 squared is 4. We want a by itself, so divide by 4. Divide by 4. Well, that simplifies to 1/2 equals a. You can either leave it as a half or 0.5. So our final answer is y equal to 0.5 or 1/2 x squared. So that is the end of 9.8 and the end of chapter 9. So make sure that you've paused, you've taken notes, or you've gone to the textbook to take notes, and you start the homework. Okay, guys, bye.